So I'm sharing my screen. Good morning and good afternoon and good evening, everyone. So this is Jay from Supermicro. So for today, that I mainly focus on the hardware point of view for XG version and applications. So I think that not limited to 5G, but also like 4G and 6G that we are discussing for these events. Okay. So quickly, that go over our company profiles. So Supermicro, probably you know that we are in the computer industry and provide high quality and reliable compute solutions. So our products covering the servers, workstations, and the motherboard, and that we provide advanced features, efficient performance, and scalability and security of our servers. So, and can be used for the data center, enterprise level, and particularly that for these, if we are industry at 5G and communication applications. Our company is headquartered is in Silicon Valley, San Jose area, and that we also have big site in Netherlands, covering the Europe and MEA area. And also, like, we have Taipei office that to cover the Asia and the Pacific Ocean. So in respect to the ORAN, that we are leading the effort that for Working Group 7. So if you're familiar with the ORAN, the scopes that Work Group 7, it is mainly for the hardware white box. So we have a few scopes that are for the deploying scenarios and the base station classes and indoor picocells, outdoor microcells, and the IABs, and also for the outdoors front hall gateways and the network energy saving features that we are discussing. So we feel that for the hardware, there's a key component for ORAN lines that it's in addition to like Working Group 4, which is highly being active, discussed, and also this is the key component that to enable the ORAN so that we can contribute to it. So we are mainly contribute to Work Group 7 for the reference design, and this is one of the examples that I quoted that from the ORAN specifications that what we contributed to. So able to provide our the reference design of the ODUs and OCUs. On the right side, that you are able to find that the white box design for the part that we contributed to it. So it is one of the examples that for the Supermicro ODUs that we have for the industry that to use and enable 5G ORAN applications. So move on to the next. It is the ORAN Architect. So that our view it is that to enable from 5G that from all different functions, from the radios that to the 5G base stations, and also that to 5G cores. So and we feel that so there's three domains that are from the hardware point of view that we are able to contribute to. So the first one, it is the capacities. So and the second one is flexibility, and the last one, it is the all different verticals that we are able to contribute from the hardware. And also, like I put all these different scenarios that are from the outdoors that are to the edge servers, and that to high performance Hyper-E servers, and that up to edge data centers and the regional data centers that with all different capabilities and the scalabilities. So to enable all different applications of a 5G and also and 4G and 6G. So all these servers, it is being compliant with the ORAN lines specifications. So I'm going to walk you through about our visions that for these three key components. The first one, it is the capacity. So it is being enabled with from the low capacity to high capacity. So most people that probably in the industry is looking at the high performance, but also that we feel that it's being low capacity and that for some applications, the low capacity and that a need deployment will be necessary. So for example, like that all-in-one portable solutions that it can be used that in the small or portable applications that can be in research in some outdoor deployment, and that it can be all integrated into one hardware component like a servers, so including like the DUs, CUs, and the RIC, and also like the 5GCs, so that it will help that to provide very low cost, but also that it's able to for the demonstration purpose, that for to enable the latest technologies. Also that it can be used that for the low capacity or compare with the commercial deployment or of a public network. It can be used like for the private 5G node. So either for DUs or RUs or DUs, CUs and RIC. So also like for 5GC with a lower capacity. So with the high capacity requirement, so we are able to provide individual hardwares or that with a multiple node hardwares, so to enable public 5G and public 5G RAN or public 5GC node. So and also like with all different applications that provide a unified servers that are with all different applications, such as like the AMF for the so also like on top of the UPF or the application servers that can be deployed on the same hardware servers. So it can be that a highly scalable from a smaller size that to the medium, large, and the extra network capacities. So with all the different need of the applications, from the academias that to the industry, and so on. So based on so we have a wide range of server portfolios that we are able to walk you through in the next couple of slides, and that it can be highly configurable with our individual server applications and configurations. So the second pillar that we think it is that for the hardware point of view, it is flexibilities. So it can be used with any of these network node, so such as like the DUs and the CUs that with it's being widely used across the industry and adopted by our the partners with our Supermicro partners. So and also for the RIC, like I want to echo that with the previous discussion, like the heterogeneous RIC. So it have all different requirements and higher computation requirements that to collecting data and like to have a more storage to store the data. So for all different applications, can be like the 5G application only, or that it can be like the 5G plus that are Wi-Fi or different technologies. So or this can support all these requirements. And also like for the edge servers, like other edge servers, like SMOs, like the virtualized OLTs that we are able, we have our optimized applications that for these capabilities. So, and also move on to the 5GC that it is have different capabilities that for the BSS and OSS for 5GC and IMS. So like AMS, like the UPF and like the AA servers and the policies and authorization, all different functions that we are able to have all different capability, all different workload that to enable those applications. So or that or these can be all these functions that can be in together and sitting with all-in-one solutions that we can provide, being more flexible to accommodate all different needs. So from the low capacity to high capacity situations and scenarios. Not only for one network, but also like it can be sliced with all different network slicing functions that are to enable different multiple networks, such as like the neutral host environment, and also like to accommodate all different barriers, the quality of services. So for the network deployment or that for the research purpose. So I think that mostly that today that we are discuss about 5G, but also that it can be unified as one service that are to enable 4G as well. So we're still in here with our partners that are that 4G it is widely used and take the network all over the world. So it can be in some of the scenarios that it can be deployed both for 4G and 5G that we are working with our partners that are to enable different technologies that are within one unified server situations. Also, like for 6G, we also that are to shape the hardwares for it has a higher requirement that we are going to talk. So in the next slide. So in addition to the real network, our servers is also like have the capabilities that are to be applied into the test instrument. So for 5G testing, 4G testing, or the network security testing, flooding testing, or different scenarios, or even like for the network emulators. So it can generate a significant network traffic that with thousands of devices, that the thousands of the data that can be applied with a high capacity servers, and that it's being highly configurable for all different situations that are for the industry or for the academia that to use.
Jay, Ashutosh,
Yes?
So I'm just curious. You have something we're actually trying to propose for RRSA somewhere. You want to discuss that?
Sure.
Do you want to discuss like new architecture, new framework that IEEE could consider to standardize? Do you have that in your presentation?
Yeah, so we have some more that to discuss in the next couple of pages.
Okay. Thank you. Yeah.
So that we have a variety able to support all different with the hardware configurations that to support all different variety of workload such as like the general purpose workload, the compute intensive workload, and also memory intensive workload, or the storage, and the GPU enabled. So, and also like high performance and the computation, so that it is being enabled, that with being configured that to enable all different network scenarios. So that we also like work together with our partners, that we being flexible, that particularly for 5G DUs, that for the inline processing and the local side processing, that are being there are some debating that across the industry. So we are being flexible, that to provide our hardwares that are to be compatible and that to work together with the ecosystem, such as like the chipset companies and also like the platform companies. So, and also with all different acceleration cards that are to, I put it on the right side. So not only for the DUs, but also for the 5GC UPF point of view, so that to support all different network capabilities from the FDD to the TDD, also like the narrow band, also the wide band. So the last pillar that we are going to talk about, it is like the from the verticals. So I use that for the ITU, that triangles. So starting from the EMBB that to the MTCs and ultra reliable low latencies. So what we are think about is that with all different technologies that we are able to apply. So with all the enable or our hardware capabilities and applies that all into the new vertical infrastructures. So as of now, that it is pretty the hot topic. It is the AIs. So how are we going to apply all different new hardware configurations and environment that into and to benefit the industry? So, for example, like to improve the like the performance. So, such as like AI aided that network performance. So, for example, like the beamformings, right? So, we have the strong computation hardwares, such as like a GPU servers, and collaborating with the and being optimized. So for from the and also like the two with the associated with the CPUs and also like the GPU and the DPUs, so that to enable the advanced the AI computation requirement. So, and that as for from the hardware point of view, so how AI it is working, and we are able to take advantage of the AIs. So, for example, like to provide and to deploy all different like the sensors, right? So on the hardware node. So I think that from the industry point of view, that we are talking about like the measurement, and that for each network node. So on top of that, how are we going to look into the hardwares, right? So from the hardware component point of view, so we want to understand that how the energy being saved and how it is being consumed first, so that we are able to deploy our the sensors on top of each hardware component. So and that through the closed loop and feedback towards our sort of our the software from our partners, that to optimize the network energy savings. So to like to turn on and off, and that put the like all different state of the CPUs, also like and to collaborating between all different hardware, the hardware component and entities. So, and that to applicable that to certain applications. So this is that what we want to we want to collaborating with the industry that to enable these hardware capabilities that are to and contribute to 5G plus 5G plus and 6G, so that for this is one of the applications that we are working that to optimize optimize the hardware performance and the software performance, and that to benefit the deployment scenarios. So all these that we have is that we have it is with the hardwares, so that we are collaborating with the industry, and that for example, like we'll have a wide range of GPU servers portfolios. So from the smaller size of GPUs that to the very big that as you can see on the lower right side of these, and the data is being optimized for AI AI applications, and the data can be associated with the 5G scenarios, so to benefit the industry. So last that I just want to provide of our and align with our hardware solutions. From the first we are thinking is add-on card. So all different scenarios that for the add-on card that we yes.
Jay, I just want to step in here a little bit. Where is the proposal? What you're suggesting? I know you're talking about your products, but this is an IEEE conference. We'd like to see your proposal for RRSA. Do you have any proposal for what you want to propose in standardization? I mean, I know your talk is architecture, hardware.
Yeah, so I think that for what we are proposing is that for the hardware point of view, right? So we are thinking that hardware is the key component of the standardized. So such as like for the from the ORAN point of view and ORAN lines, that for the pre-standardizations, that what we are thinking is that how are we going to use the servers, and also like how are we going to deploy the sensors, and that to enable the new measurement, and that for the energy saving features. So which is a key for the OpEx from the deployment point of view, right? So I know that it is not being widely, so for now that there's no sense that it's not being standardized, but also how are we going to doing the similar work as that for ORAN, that to be how to standardize different servers, hardwares, and that it can be collaborating with the IEEEs that to enable these applications. Yeah.
Okay, so your main focus is standardizing some of the basic functionality of the hardware, because we cannot standardize any specific proprietary system, right? IEEE doesn't do that.
Right.
So
this is not like for the proprietary. So what we are thinking is that able to deploy certain sensors. So for example, like the temperature sensors, right? So we have like the hardware that it is running into high temperatures, and have a consumption like different the energy savings, the TDPs, right? How are we going to deploy certain sensors, certain like the loaders, and to able to provide, and that to providing to and reach certain agreement with the industry that to enable the high computation, the high computation requirement. So on top of that, as you know, that for the GPU servers has high power consumption, right? So the CPUs, the high-end CPUs has a high power consumptions. How are we going to utilize these deploy certain sensors, therefore that we are able to be adopted and being agreed across the industry, right? So that it can be into with a low traffic load or high traffic load, or that it is the burst traffic load. How can we benefit from the hardware deployment?
Right.
With
I
the
think
different
I get
sensors?
your point. I mean, it's clear now, right? I think because I was not getting that point across. So you kind of, this is, if you see some of the guidelines, document, deployment nightmare, what you're suggesting is a way to take care of some of those deployment problems using some hardware-based solutions. That's probably what you're trying to say, right?
That's right.
Yeah,
So,
yeah.
and also our vision is that it is not from the hardware point of view, right? So it is a collaboration that across industry, not so between the the hardware industry, also the software partners. So we're able to showcase in the early stage that we are able to showcase, and this is the benefit, right? And that from the POCs, from the simulations, that
I get your point.
for certain applications.
I mean, pure software-centric solutions has its own benefits and challenges, right? And we all have experienced that when you move to completely SD and NFV type, there are problems, efficiencies, and we have to get the help, some sort of a hardware accelerator, whatever you want to call it. So you're trying to address some of those KPIs can be improved using some hardware-based solution or augment the existing solutions with some hardware-based addendums, right?
Yeah, so I think that we want to collect the industry attentions that not only from the software point of view, but also like the hardware is also the key component that can contribute to this improvement. So from being the greener world, right? And so and that to improve the energy savings, right? That's energy consumptions.
Hey, do you have any kind of a graph curve? Maybe you have done some analysis. What I was thinking, I mean, this is an important item. We want to have some kind of even 2-3 page white paper, because that is within the purview of our industry connection, Open RAN. Just like we talked about heterogeneous rig, right? We got some ideas, we're going to write it up. So you have an interesting idea about hardware-based solution to augment the existing problems with Open RAN deployment, right? If you have some, you said you have done some analysis, so if you add some hardware-based solution, how is it going to improve the efficiency, optimization, etc., right? If you have those, maybe you can put those up in some kind of a white paper, 2-3 pages, and that will be a good basis, right, to take it to the next step.
Yeah, so I think that this is a good start that to force the collaboration with IEEE. So we have some studies that we want to definitely that we can sync up offline and that to contribute to the white papers.
Right. I think that is the first problem statement should have come in your presentation, because otherwise it looked like a product marketing presentation.
Yeah, I see.
Yeah, because IEEE, we usually like to see the real problems and solutions. So now that's why I've been asking you so many questions, right? Because people have been putting stuff in the chat as well. Yeah. And now we understand the problem statement. So my suggestion would be, as the ORAN Industry Connection Chair, to write up something that will have some comparison, some additional KPIs, how it's going to help, pros and cons, right? And that will help to do some interesting work, right? Right. So that would be my suggestion. And
sure.
Yeah. Okay.
Yeah, I think that let's think of offline that can and see that what we can do and collaborating and that to force or different and that to share our ideas that to and that to for the next step. How are we going to make it happen, right? And our study result share with you.
Sure, and if you have some results, that would be really awesome. Maybe you can present it one of our monthly meetings. That'll be great. Yeah.
Sure. Yeah. Yeah. For today, that probably that I'm not able to provide, but that we can
That's fine.
think of.
I mean, yeah, we have to make the problem statement, right? And I think you started addressing that, but the presentation looked like more like marketing brief, so that's why I stepped in.
Yeah.
But that's
Okay.
fine, G. You have anything else? Otherwise, Adeline, are you on the call? I know he's. I have to. Otherwise, you'll break for lunch. Because you should have Adeline from Eurocom. You have anything else to say, G? I just wanted to focus. We don't have to go through the. Yeah, I think you address a important point. It's just that didn't come across from your presentation right from the beginning. I think. Yeah.
Okay. Yeah. So I think that I think this is the last slide that I have. We want to bridge. We want to share our visions that with the industry and academies and IEEEs, so that with the better hardwares and enable the latest and advanced technologies and to solve those problems and collaborate with you. Yeah. Thank you.